Hi folks, welcome to the sixth and final installment in Related Rates lecture videos. We're going to go ahead and do one last example here. So example 10, a 10-foot ladder is leaning against a wall. If the top of the ladder slides down the wall at a rate of 2 feet per second, how fast is the angle that the ladder makes with the wall changing when the bottom of the ladder is 5 feet away from the wall? Okay, so let's go ahead and get started. So I'm going to go ahead and draw a diagram, and if this problem looks familiar to you, it should, the first part at least, because we started off, I think way back in example 3 with a ladder that was 10 feet long, and it was falling down the wall. So we're going to label this a little bit differently this time. We have our Z, or our ladder, is 10 feet long. Now, one thing that we noted from our first example is that ladder itself better not be changing length, so we could say that dz dt equals 0. Now, what can we say about the other sides? We know that x on the bottom here is 5, because the bottom of the ladder is 5 feet from the wall. And we know that dy dt equals -2 because that distance is getting smaller as the ladder slides down the wall. Now, one thing I notice we don't know is we don't know why. And what we're trying to find is this angle right here. And I know that because it says the angle that the ladder makes with the wall. So it's not like the angle of elevation in example 9 and the hot air balloon. You really have to be careful to label the diagram correctly, okay? So here's what I'm going to do. I'm going to set up an equation, just like last time. I'm going to think about what sides I have of my triangle, because I want to pick either sine or cosine or tangent. And when I look at my triangle, I realize that I have the most information about the hypotenuse, and I have information about the adjacent side. And so since I have adjacent and a hypotenuse, I'm going to say my equation should be cosine theta equals adjacent over hypotenuse. It's okay that they gave me x equals 5 and I didn't use it yet. That's okay. All right, sometimes there's just enough numbers and sometimes there's actually too many numbers. So let's take our derivative and then see what information we still need to find. The derivative of cosine is negative sine, but don't stop here. Don't forget that d theta dt. On the other side, to find the derivative of y over z, I'm going to need my quotient rule. So let me set this up off to the side. I'm going to get u equals y, du equals dy dt, v equals z, and dv equals dz dt. Plug that into my quotient rule. I've got v du minus u dv over v squared. Okay, let's see what numbers we have and what we might need to find out. On first glance, I notice I've got this z, I know that's 10, and I've got this dz dt, which I know is 0. So I'm good to go with those numbers, and I also know this z as well. I know my dy dt is -2, but it sure would be helpful if I could find my y value, because that's what I need to find. It'll be one number that'll help me achieve my end goal, which is to find the d theta dt. Now, you might also say, hey, I don't know anything about sine theta, but maybe what we could do is rewrite it in terms of opposite over adjacent, and then that would make our lives a little bit easier. Okay, so we're going to use what we know about sine, that is opposite over adjacent, and use that to help us fill out all of our numbers so that the only thing we don't know is our d theta dt. Okay, here we go. So negative, let's see, the opposite from my theta is 5, and the adjacent to my theta is that y. Well, let's leave this as a y right now. I've got my d theta dt equals 10 times negative 2 minus y times 0 over 10 squared. Okay. So it looks like over in this case, I don't need to find my y because it cancels out with the 0, but I do need to find it to fill in the, oh gosh, what am I doing? I don't need the y here. I actually need the hypotenuse. This is when it's helpful to have you guys in class so that you catch my mistakes faster than I catch them myself. Okay, so let's go back here for a moment. Opposite over the hypotenuse is 10. That looks a little bit better. Okay, well, let's see what we have now. Negative 1/2 d theta dt equals negative 20 over 100. And I'm going to multiply both sides by negative 2, or the reciprocal of 1/2. And let's see, d theta dt equals, once I multiply and reduce, I will get a positive 2 over 5 radian per second. And so let's zoom back out for a moment and see what this means. So at the moment that the ladder is falling at negative 2, sliding it down the wall, that angle is actually getting bigger. So y is going down by 2, but my angle is getting bigger by 2/5 radians per second. Okay, so there you have it, our final example for related rates. I wanted to do a bunch of extra ones this one because I think it's good to have a lot of different types that you're aware of how to do, and hopefully those align with the ones that you'll find in WebAssign. All right, if you have any questions, shoot me an email, send me a message on Canvas, send me a message through WebAssign, and I'd be happy to help you out. Thanks so much, folks.